Today we have Ross Burke, Senior Security Consultant with Mandiant. He's going to talk about network traffic analysis beyond Wireshark. Ross is a principal security consultant and an adjunct instructor at the University of Houston. He has extensive experience in enterprise information security. He helps organizations improve their security posture and has developed training programs for threat hunting and SOC analysis. And he loves the traffic of Houston. Welcome.
Thank you, thank you. Can y'all hear me? Is the mic good? Oh, good. All right, perfect. So like I mentioned, Ross Burke, and we're going to talk about network traffic analysis beyond Wireshark. I know most folks, we kind of associate network traffic analysis with Wireshark, and that's not a problem. I'm not here to say don't do that, but I'm here to maybe expose some things that we could do differently to kind of aid that analysis process, right? So Ross Burke, principal consultant, instructor at University of Houston, instructor at Berkeley. I'm trying to look for a fourth job. If you want me to work for you, let me know. I can't say no, apparently. 7 years of experience, and I do things like SOC optimization, SIM engineering, threat hunt programs, security janitor, just in general, really. And I'm a network traffic analysis enthusiast, which is why I am here today. That is my angel of a son there. I also have an 8-month-old daughter who has kept me up since 4 a.m. today. So maybe next year she'll come and be on this slide when she lets me sleep. Okay, so the current state, right? Our toolbox, for the most part, when we do network traffic analysis, is interesting, right? So let me set the stage, right? It's 8 a.m. You log into your workstation, you have your coffee, you've only had 4 hours of sleep because your daughter woke you up, and you're just ready to go, but not really, right? But your network operations center analyst, somebody, reaches out to you and says, hey, executive team, their segment had some sort of weird stuff going on Friday. They didn't actually bubble it up to us until Monday, today. So you have 4 days of network traffic that they just kind of handed to you, right? And you're just supposed to find evil, I guess. And what most folks do, and rightfully so, this is what we're trained to do, this is what we're told to do, is use Wireshark. I get it. That's what we're told to do, but opening up a multi-gig PCAP and packet capture in Wireshark, it's not a good time. If you haven't done that, try it. Capture traffic on your host for 24 hours, open it tomorrow, and then watch how long it takes for you to open that, right? When you try to run a search, I want to look at HTTP traffic in this PCAP. It's going to take you 5 minutes to get that back, and I don't know about y'all, but when I use Wireshark, I don't know the exact thing I'm looking for necessarily. It takes time for me to find what I'm looking for. So having to run HTTP as your search, get back nothing that of value to you, you got to do another search, that's more, 5 more minutes, so on and so forth, right? It's a problem. So we need to kind of shift this a little bit, and instead of looking at Wireshark as our only solution, let's look at some other ones that are probably not surprising to you all. Some of them you probably heard of, but we just need to use it in a different capacity. So we'll talk about that. So let's expand our toolbox. Wireshark is still there. Cute little picture in the back, it's still there. We still want to think about it, but let's actually open up what we can actually do with something else, right? So the first thing we're going to talk about, the first tool we're going to talk about is T-Shark. I know a lot of my students are here from the University of Houston. You all get A's, that's great, but they all heard me talk about T-Shark quite a lot. I'm a big fan of it. I showcase it in all my classes because it is powerful. So cool picture. Why T-Shark? So it is Wireshark, hence the name T-Shark, but it's on the command line, right? So first things first, you look awesome when using this, right? Imagine in your room, 8 o'clock, and you're just hacking. You're not, but you're running a search in T-Shark. That's great. You can pipe data from T-Shark into other command line utilities in Linux. So awk, sed, grep, other analysis tools that you might have sitting on your box. So you can really easily use the functionality of Wireshark without loading it into a GUI that has all the dissectors and parsers and everything in pretty colors. That's all great. We can just use it on the command line and streamline that analysis, make it a lot easier for us, right? And it opens the door for you to perform sweeps. Again, this is command line utility, so I can just run a grep for the word, .zip across my whole PCAP. You can do that in Wireshark, sure, but again, GUI might take a long time. Running, give me all the packets in verbose mode on T-Shark, Search for the word zip, what do you get back? Search for the word Mimikatz, what do you get back? Just sweep the data, right? And you look cool, it's command line. That's why we're in security, right? Trying to look cool, that's all that matters. So to kind of demonstrate that feature parity, right, we can use T-Shark to do a lot of things that Wireshark can do. So this is an example command, right? We're going to read in our PCAP. We're going to use the capital Y command, which is just saying, I'm going to pass a display filter, like you would in Wireshark. My display filter is tcp.port 80, or tcp.port equals 80, excuse me. And so I'm trying to pull out HTTP traffic, ideally. And I'm going to write that to a new PCAP. So in the red box there, sorry in the back if you can't see this, there's 31,000 packets in my original PCAP. When I run this query, or this command rather, now I have 2,300. So I reduced that substantially. Maybe if this was multi-gig down to 50 megs, then I can actually open it up with Wireshark at this point, right? So that feature parity still exists even though we're only using the command line. It also does statistics. So if you've used Wireshark, all the cool functionality of statistics is still available. It's a little bit uglier to use, right? I have to use a -q to make my query quiet so it doesn't display all the packets on the shell. But I use the -z to use statistics. So I'm going to look at the protocol hierarchy and see what protocols do I have embedded in my PCAP. This is just one example of what you can do, right? You can do endpoints, conversations, HTTP, SMB mapping, all sorts of fun things that you can do natively in Wireshark, we can do in T-Shark. So feature parity absolutely exists, no reason not to use it, and actually you can do even more with T-Shark, and we'll talk about that. I mentioned sweeps. Here is one example of what that looks like. There's plenty. Again, if you've taken my class, you know I love the user agent string. It's my favorite host header, or sorry, it's my favorite HTTP header. So we use the -t switch to say we want to display only the fields from our results. So we're looking for when the http.request.method equals get, only get requests, and I want to extract, that's what that lowercase e says, only user agent. Give me only the user agent strings. That's all I care about in my whole PCAP. Sort, unique sort. I want to get a unique count of the number of instances of each string, user agent string in this PCAP. And what does that look like? Again, sorry for those in the back, but we get a running list. It starts with 41 hits on Microsoft Bits user agent in this PCAP, and it goes down to one instance of curl as the user agent in my PCAP. So already, without even having to open my PCAP, I have investigation starters. How often do you expect your users to use curl in your environment? Maybe a lot, but why was there only one instance of it? We also have Wicca agent, one instance of that. We have 2 instances of PowerShell as our user agent, and then we have 5 instances of there's no user agent. The absence of a user agent is anomalous in itself. The only required header in HTTP 1.1 is the host header. But most people don't remove their user agent string, right, when sending web requests. So the absence of it is anomalous. I want to go look at that. Again, I haven't opened my 50 gigabyte PCAP. I just ran this quick sweep, and I have investigation starters just like that. DNSQuery.name for long tail analysis. So users are pretty static. We like to think they're not, but for the most part, we browse to the same sites, right? I go to Facebook, I get my data stolen. I go to TikTok, my data is being harvested. I go to ESPN every day. That's it. How often do you go to a site where you're the only person in your organization that initiated a DNS query for that site? Not pretty often, right? So we do the same thing, that same mantra we've been using of sort, unique sort. We extract our dns.query.name, so give me all the DNS requests, and sort it and give me a unique count. So we have some local DNS resolution, fine, sure, but we have 2 hits for 623start.site. So without me, again, opening this PCAP in Wireshark, I have another investigation starter. If you go to VirusTotal and type in 623start.site, you'll see this is a malicious domain, according to like 9 people or so. So I've already had hits. I haven't even opened my PCAP yet. And this is a relatively short command to run. It'll parse through all this data real quick and spit you out output that's useful for you. Intel. Using Intel in packet captures is a hard thing to do without relying on commercial software, core lights and your NDRs and all this sort of fun stuff. But we can actually do that using T-Shark. So first thing we need to do, extract the field you want, DNSQuery.name, IP addresses, whatever we want. Check that IOC against an Intel feed. Little bit of legwork there. We have to write the one-liner or the command to do this. But once you do it once, it's essentially automated at that point, right? And then we profit. We get hits. So this will be a situation that it'll look like a blob of text, but I promise you it's just trying to illustrate something. We'll look at that in a little bit. But what I'm going to do is I'm going to extract the DNS.A records. Often you'll find A records come with multiple IP addresses for a single query. So I'm going to remove the comma-separated value, add a new line. So I have a new line list of several DNSA records, IP addresses. And then I'm going to sort unique. I only want the unique counts because I don't want to rate limit myself when hitting the VirusTotal API or whatever I'm using. I'm going to store it in destip.txt. So I have a running list of A records and a giant text file. Hopefully not giant, but a text file nonetheless. And then this is where it gets ugly, but I promise you do this once, you write the code once, then you're squared away. I have a while loop where I feed in that text file. I check against abuse IPDB, which is a well-known tool that does abuse reporting. It's crowdsourced about IP addresses. And you can look at GeoIP location information, and all I do is I pass all these DNS records to this API. I, of course, have my API key in the command, which is not there, so don't try to steal my API key. And then I output it to output.txt. What does that look like? I have this here. I tailed output, and we have a IP address, 95. whatever. It is a Bulgarian IP address, and it has an abuse confidence score of 0, which, again, this is crowdsourced, so when it comes to confidence scores, you got to take everything with a grain of salt. But do I do business with Bulgaria? Do I want that in my environment? I don't know, maybe not, right? But it's an investigation starter nonetheless. So then I can just piggyback off of this, use T-Shark, and do a search for when IP address equals whatever this Bulgarian IP is. And all of a sudden I have, 5 packets. 4 of them are SYN packets from a ephemeral port internal to a destination port of 25. That is an external Bulgarian IP address. And then I get a reset, eventually, from that Bulgarian IP address. I don't know about you, but I don't know how often one of my users just decides to send a SYN packet to Bulgaria multiple times, and then Bulgaria says, no, go away, for right now. Could be beaconing, right? Could be check-ins from malware. We don't know. But again, these are investigation starters. Haven't even opened my PCAP. So I've already done carving out, sweeping on user agents, long-tail analysis on DNS queries, and enriching IP addresses without even opening this 50 gig or whatever gig PCAP. So T-Shark's my favorite. If you gave me enough time, I can spend a whole hour talking about this. I read a book about it, so if you want to talk to me about it, I'm more than willing to waste your time. That's T-Shark. So cool, T-Shark's great. Seen the light on that. What's next? Zeek, and that should be no surprise to anybody. Zeek is a very popular tool, bro, as some people call it, if you're, want to call it that. Cool logo. Why Zeek? It's a great tool to compartmentalize your data without you having to do any legwork. Most people, rightfully so, associate Zeek with being a passive node where you span traffic to it. It writes log files according to, is this HTTP traffic? Is this DNS traffic? And then we grab those files, ship it off to a SIM, and now we have that telemetry in our SIM, correlation searches, whatever. But why not have a local instance of Zeek on your analysis machine, right? Why not just have it running there, and then you can pass it your PCAP locally, look at the log files, and investigate it that way. So just like I mentioned, compartmentalize your data, and gives you quick wins on weird activity, file downloads, web traffic, and there's a whole slew of output files, and the various structures of those output files are available on Zeek's documentation, but very useful tool. So let's walk through how we could actually use this, right? So all we do is Zeek R my PCAP. That's it. And now I have 16 or so log files that are my Zeek log files that I can start to carve through. Let's talk about file.log, a very important one. As files get downloaded or uploaded, these will be grabbed and thrown into a file for you to look at later in the log file. So if you haven't opened up a Zeek log file, it's pretty ugly in the beginning, right? There's a lot of metadata in the beginning. So in the beginning, there's what the fields are, id.original_port, file name, all sorts of things, but it just helps you understand what you're looking at when you're investigating that, or rather opening up that log file. Here, we have a situation where somebody went to a raw IPv4 address, 128 dot whatever, and they downloaded a portable executable from a raw IPv4 address. Just from looking at file.log, I was able to find this. So there are two important fields, really just one, but more or less do the same thing. The file UID or the UID. These are important strings that are unique for a stream. So the 5-tuple, source IP, source port, dest IP, dest port, and protocol. So as Zeek reads this data in, it'll create a unique identifier for a stream. And then all I can do is I can just grep for that string across all my log files, and I can get back full context of the connection, DNS if that exists, the file, HTTP, all sorts of good data. So I'm going to do exactly that. I grep for that file ID string across all my log files, and I get a hit on files.log, which is what we're looking at here, http.log, and pe.log. http.log has a couple of interesting key points here. The raw IPv4 address and the URL, and the file name is 86607.dat, and the user agent was curl. Remember that curl hit we had, right? This is starting to put the pieces together. So we have curl being used to download a .dat file. .dat files are not portable executables, but it's being considered that by Zeek. So it sounds like whatever that file is probably masquerading as not being a portable executable when in fact it actually is. And we get that hit because Zeek looks at the file header, right? Looks for that MZ, that magic byte, and it'll extract that and throw it into the pe.log. And so we have a hit on something trying to maybe obfuscate what it's actually trying to do. Again, haven't opened my PCAP, why not have Zeek running locally on your system? x509.log, looking at certificates. Just because things are encrypted doesn't mean we need to give up. Let's Encrypt is a very interesting utility that makes my life easier when trying to set up web servers or whatever, just to kind of test things out. Threat actors also use it because it's free and you can automate certificate renewal. So why not just grep for the word let's encrypt across the x509.log and see if we get any hits, right? How often do you see reputable organizations using Let's Encrypt? Do I expect Apple to use Let's Encrypt? Absolutely not. I expect them to use well-known CAs, and so when I do that, I get several hits, and I get the CN of those sites. So now I have several sites that are in this PCAP that I know I can go maybe take a look at and understand why are users browsing to sites that are leveraging these free services instead of well-known CAs. More investigation starters, right? Now we can look at this PCAP and investigate it further and just pull out when people are browsing to these domains potentially. SMB, if you had never done SMB analysis, it sucks. It's awful, it's terrible, so I don't recommend doing it manually, but Zeek will help you in that process, right? So SMB mapping will actually map out the shares that are mapped using SMB. So we can cat that file real quick just to show you what it looks like. We have our metadata at the top, we have our fields, and then we have our data. If you're savvy enough, you can see there are a few instances of an internal IP reaching out to a public IP over port 445, which immediately, if you've been through WannaCry, sorry for you, but this should perk your ears up immediately. we see somebody mapping a share externally over IPC and MISE. So immediately that's a little interesting. So I'm going to take that UID we talked about, that unique identifier. I'm going to grep for that across all of my log files. And I get back several hits. But one thing we're going to look at is now we have a named pipe called SRV SVC, and a binary that was passed in the files.log called server.exe. I haven't analyzed SMB manually. I just grabbed the SMB mapping and I grepped and I found a binary now. So now I should pull that out, do my triage on it. Is this normal? Why are we using SMB to go out and download files on the internet, which is pretty odd. So investigation starter, another one, quick win, right? Time. Okay, Zeek, awesome. T-Shark, great. What's next? Silk. This is probably the lesser known one, and that's okay. It's a little bit of a trouble to work with. We'll talk about that. Here is a picture of Silk. They don't have a logo, so I just grabbed a picture off Google of Silk and threw it on there. So you should hire me for making their logo. It's all about flow analysis. So instead of looking at payloads and doing that monotonous task, potentially monotonous task, of trying to investigate every single payload in a PCAP, I can just look at flow data, the 5-tuple, including some other metadata, and just see if anything sticks out to me. What looks potentially odd, right? Syntax is hard, but it's command line, so it's absolutely worth it because you will look awesome. Put a hoodie on, do this, you'll look great. You can do things like spot longest sessions, top talkers, anomalous protocols, uncommon ports, all sorts of fun things you can get, again, without even opening up your PCAP. I'm gonna keep saying that until I die. Silk workflow, it's a little bit more nuanced than just Zeek-R, give me data. But it's worth it. So we're gonna transform our PCAP data to Silk data, data that Silk can understand. So in this interesting example, we have a rooster chicken thing. That's our PCAP, and we're going to transform that into a crocodile. That's what that's trying to illustrate for some reason. Then we're going to filter out our flows of interest. So we transform our data from PCAP to Silk data. We're going to filter out things we care about. We can display the fields we want, right? We can cut, more or less, the fields that we want. Or we can perform statistical analysis on the fields that we care about. What does it look like in practice? Let's prepare our chicken to turn into an alligator. Let's read our PCAP data so that it can be translated into Silk data. There is an ugly tool called RWP2YAF2Silk that you can use to do this. You pass it a PCAP, you say, give me flow data, right? What does that look like in practice? Pretty simple. In PCAP, out my .rw, I can name it whatever, my flow data. So pretty easy. So we prepared our chicken to be an alligator. And now we're going to filter that data. So the cool thing about it is there's this idea of passing or failing your filter. So if I want to look at TCP.port 80, things that pass that filter, meaning things that are TCP.port 80, I can do one thing with. And then I can also say anything that fails, do something else with it. So I can kind of leverage a filter to look at things that fail or look at things that pass my filter. So once we pass a filter, we can't look at the data. It's still binary, and that's by design. Silk tries to keep your data in a binary format as much as possible to ease that analysis process and ease the translation process. So you can't just look at it on the shell. If you just run a RW command and standard out your past filter, you're going to get back nothing. It'll say, I'm not going to do that to you. What are you doing? You don't want binary data on your shell. Stop it. So this is my filter. I'm going to look for all communication, multicast, broadcast, whatever the case is. I want all of it. I want the protocol to be TCP, protocol 6, and destination port 80. And I'm going to pass whatever, I'm going to have whatever passes that filter go out on standard out. Just go out to standard out. Then we can use a tool like RWCut, and I promise we'll go back to that previous one a little bit, to actually manipulate that data that passed my filter. So RWFilter, again, filters my data, and then I'm going to use RWCut to say, I only want the field source IP, source port, des IP, des port, and the bytes for those that flow communication. What does that look like in practice? We have this ugly thing. Again, think this is worth it because we look cool. RW cut, field, SIP, sport, dip, deport, bytes, and we get this. So at this point, we have a chart, I guess you could say, and you can actually build a whole report if you wanted to based on your flow data of the 5-tuple, or rather 4-tuple, we're missing protocol, but it gives you potentially who are the loudest talkers, who is talking the most. We can do things like look at the longest sessions, and this is just the starting off point, right? This is using RW cut, which is, I feel like, more for reporting and not really for analysis. That's where things like RW stats come into play. And there's actually like 20 or so RW somethings in the Silk toolkit. I'm only talking about a few because we're not going to be here forever. But we can create bins of data using whatever we want and derive investigation starters out of that, right? So we can look at top talkers, external sources, so on and so forth. So RW stats can be used. Let's look at the source IP. Give me the top 5 source IPs with the number of bytes being that aggregate value. The number of bytes calculated, who is the top talkers in my environment, or rather in my PCAP. And so that's what this huge thing looks like. And now we have a chart of our source IP, the number of bytes, the percentage of those bytes related to the actual PCAP itself. And so we see we have like 11 million so bytes from this 10.0 address. We have a couple external IPs that are a little bit more talkative than usual. So thinking of investigation starters, we can look into this. We can take this even further and pass a ugly filter, I admit. In this one, we're looking at the source CIDR. So we're trying to remove RFC 1918 addresses. I realize now that I missed 192.168.0.0/16. I couldn't change the slides in time, so forgive me. That should be there. But we want to remove the source where the source IP is internal. So the way we do that is we do a filter for source CIDR, RFC 1918. Anything that fails that filter, meaning anything that is not source IP internal, pass it to standard out. I pipe that to RW stats. I look for the source IP and count top 5. And now I have a top 5 list of my biggest count of records, meaning number of flow records. We can actually translate that to bytes if we wanted to. But I have investigation starters because this 208.187 address has 125 records of flow data and is clearly, by far and large, our biggest talker in this PCAP. Why is that? We can enrich that IP, do our analysis, so on and so forth. We can even take that a step further, same filter, but instead of doing just the source IP as our fields for the RW stats, we're going to do source IP and S-port. We'll look at bytes, and now we have a better picture of what's going on. That 199.232, the source port is 443, and we have 8,700, almost 1 million bytes being sent from that port. So this is our biggest web talker. We can assume that, right, as port 443. So maybe I want to peel that back and understand why we're getting so much data from this IP address. Is it authorized? Is it not? That's Silk. I'm telling you, it's vast what we can do with this thing. It takes I could do a whole lecture on it if I wanted to. I don't really want to do that, though. It is hard to use, but I promise you it's worth it. Last tool, Snort. Snort is awesome. People love this, I hope. It's kind of the back end for pretty much every single network appliance you have in your environment. But most people, just like we do with Zeek, assume it to be an out-of-band appliance, maybe in line if it's doing some IPS functionality like a Palo would. But it's out of band, you span traffic to it, and you get alerts, and you investigate those alerts. I ask the same question. Why not have Snort running locally on your analysis workstation like we would do with Zeek, right? Why not? So, cool logo, better than Silk. Why use Snort? Community rules are crowdsourced, so it's, again, grain of salt, but it can give us investigation starters, potentially. It can uncover IOCs. We'll look at one in a little bit. You can create your own, or you can pay $1,000 to somebody else, and you can just subscribe to premium subscriptions. Maybe don't do that, but you could if you have the bandwidth and the finances to do it. But the reason I say create your own is why not have a running total, or rather running custom rules file that you have on your analysis workstation. So as you do things, a year from now, you have rules that you wrote that you can now use for further analysis in the future, right? So just have a running local, custom rules file. And so this can expand and expand and expand. As new vulnerabilities come out, typically vendors will provide snort signatures if they're nice enough to do so. Grab them, throw them into your custom rules file, and include that in your snort configuration, and now you have further detection capabilities, potentially. And like I mentioned, most of the backbone of many IDS, IPS appliances is snort. So the snort, or rather the syntax of snort, Suricata is, major player as well. But this is a translatable skill. So if you learn how to read snort syntax, you can use this on a FireEye appliance. You can use this on, or Trellix. You can use this on a Palo appliance. You can take it other places, right? And of course, this is a marketable skill, interviews, all that sort of fun stuff. Running snort. So snort.conf is the life and blood of snort version 2. Snort version 3 is relatively new, so it's now snort.lua. But I'm going to focus mostly on snort.2. That's what I got into the industry at Alert Logic doing. So snort.2, or snort2 rather, I'm going to focus on snort.conf. This is where you include what preprocessors to use, what output you want to do. Do you want to write it somewhere else? Do you want to send a message somewhere else? Whatever you want to do. And also, what rules do you want to include? So there's your custom rules.rules. That's just a name I made up. Exploit.rules, backdoor.rules, all these community rules you can choose to exclude or include in this snort.conf file. What I have here, this is an eye chart. I mean, nobody can read this, barely even me, but this is just an example of what a rule would look like. I catted backdoor.rules, and there's just a bunch of snort rules in here for you to look at, right? So what I do is I run snort-c. I'm going to pass it my snort.conf file, which is my custom configuration. And then I'm going to read in my original PCAP, and the output goes to var log snort. So now I just navigate there and see if there's any hits, right? Did I have my PCAP? Did it have any hits for snort? Did snort signatures find something potentially malicious for me to look at? And fortunately, or unfortunately enough, in this PCAP it did. So we have a bunch of hits here. Some might not be useful, some may be useful, but these are all default community rules. At the very top, there is a hit for a overflow attempt, which could be a false positive, right? Whenever I do analysis, I always assume false positive and try to prove it to be true. So I'm going to take a look at that further, but again, haven't opened my PCAP yet. We get our source port, desk port, source IP, desk IP, so now we have more data about what was actually hit on. And then in the top red box, you don't see it, there's like a 7, 8 character, or rather digit. That is the snort ID, the snort signature ID. So I can grep for that across all my rule files and see what is the actual rule that triggered this alert. Time and time again, I talk to consultants, I've talked to students. As soon as they get an alert, they immediately think this is bad, true positive, I need to go investigate it, and they waste their time on something that is not actually a true positive. And I ask them, did you even read the rule? Like, why did it fire? No, I have no idea. So you just read overflow attempt, and you're just like, I need to go and re-image this machine. You get to understand what actually fired. Why did it fire? So grep for that signature ID across all of our rules. We get back the exact snort signature that fired. This is a community web miscellaneous rule. It's looking for 1,000 characters of some sort, and it fired on our PCAP. So now I have more context as to what I'm looking for, which is what we want as analysts, right? We want context. We can use T-Shark, see, we're piggybacking off of what we learned earlier, T-Shark to isolate that stream, isolate those packets, rather. So I run a filter for the IP address equals that IPv4 address, that external one, that was in that previous log file. Look for where the protocol is HTTP, give me the source IP, dest IP, give me the request full URI. These are just fields in T-Shark, or rather Wireshark, that we can extract using T-Shark. So I get something like this. Now I have a source IP, which is internal, a dest IP, which is external, and my URI. And what this looks like is there is somebody on the inside making a web request to a raw IPv4 address, again, which is anomalous in itself, and it's looking for a huge set of numbers and letters on the URI for the file eozxc6q.gif. And then a .bmp file. Why is it making multiple requests to the same site for different file names that are looking pretty anomalous? So we can actually follow that stream, much like we would do in Wireshark, right? Right-click, follow TCP stream, HTTP stream. Do the same thing in T-Shark. And now we see we have a post request to that raw IPv4 address. We're submitting form data for some reason, and we're uploading a file called fa1d.bin to this public-facing web server over a raw IPv4 address. Pretty odd. I don't do that. Most people don't do that. So I want to investigate that, right? Investigation starters. So, takeaways. That's our new toolbox. You notice we still have Wireshark there. I'm not going to tell you not to use it. Definitely use it. But I want to kind of bubble up the other options we have, and let's talk about those real quick, just takeaways. T-Shark, command line Wireshark, you look awesome using it. You can use all the functionality of Wireshark and even more, right? We can pass this to other tools, and it's my favorite. I can talk for hours about T-Shark because I'm a nerd. And then we have Zeek, compartmentalizes your PCAP data, right? Several log files are investigation starters potentially. Silk, flow analysis, hard to use, but worth doing it because you can investigate your PCAP without even doing much legwork outside the command, and we just have the 5-tuple flow analysis data quick and easy. And then Snort, investigation starters based on community rules, our rules that we want to write ourselves, and we create that and have that running for however long we have that analysis workstation, right? Or ET Pro if you have big bucks and you want to do that. Last few takeaways, they're all command line tools. You know what that means, right? We look awesome while using it, and that is all that matters, and that's why we're in cybersecurity. And if you want to analyze more PCAPs, you want to get practice doing this. I always told a story a couple years ago. I used to just watch the Texans when they were terrible. I would just open up this website, download a PCAP, cry about the Texans losing, and analyze traffic. Just learn. Just do it, right? So malware-trafficanalysis.net, there is actual malware here, so don't do this on your corporate laptop or else you'll get fired, and that's not my fault. Questions?
Can you give an example of how long does it take T-Shark to analyze a file of a known length, a couple gigabytes, Wireshark? Thank you.
You said T-Shark specifically? So it is, I don't have a percentage I can tell you right offhand. It does use the same dissectors and parsers that Wireshark does, so there is still some overhead there. It's not as fast as like a TCP dump, but TCP dump is an analysis tool. So you have to kind of pick and choose your battles. It's not the silver bullet, but it is by far and large a lot faster. No GUI, no pretty colors, none of that stuff, right? So it's by far and large faster, and maybe even run and try it, right? Download it or have a huge PCAP, run it with Wireshark, see how long it takes to load. Do the same thing with T-Shark, compare the two. But I don't have the number offhand. That's a good question, though.
Well, you answered me on why you didn't say TCP dump. I don't entirely agree with you, though, that it's not an analysis tool.
Okay.
I'd like to hear why you think. I was going to ask TCP dump versus T-Shark.
Sure. Write me a TCP dump filter that extracts the user agents. You can carve out PCAPs quick. You can read data quick, pipe it to the command line, grep for things, right, using the ASCII, all that. But you can't do this enriched stuff that you can do in Wireshark.
I would say you're focusing almost entirely on the payload, though, right? You're not focusing on any of the network attributes, fields, or any of the different layers. Okay.
Yeah, that's fair. That's fair. Yeah, yeah. Wait, you got one in the back.
I would like to ask for your thoughts on IPv6 because it seems to me that I'm sorry, I know I figure that reaction was going to come.
Can I have no thoughts? Is that okay?
No thoughts at all? Because in my opinion, it seems to be that most of the security field just completely ignores it and just says we're just going to block it entirely.
Sure.
in which case I can ask, well, what happens if I just start tethering on my phone, which does have IPv6, and now I just plug it into the network, and now I'm handing out IPv6 addresses to the entire network.
Sure.
And now I can man in the middle attack everyone, and no one's really looking for IPv6. And so it makes it very easy for me and possibly undetectable to most people who don't care or know to look for IPv6 or even recognize it, and just start attacking that way.
Sure, it is definitely a blind spot in this industry. We've been talking about it for so long. There wasn't just a recent exploit via IPv6 that just came out recently. That's a pretty big deal. I don't have any nuanced thoughts about it because I try to blank it out of my mind because I don't want to handle that. I'll let somebody else that's smarter than me, that deals with network security on a much granular scale than me. But it is, I agree with you, it's definitely a blind spot. We can do all sorts of evil with it, and it's definitely a gap. I agree, 100%.
All right. I think that may be it.
All right, thank y'all.
Round of applause.